how NADH pumps out electrons, which make hydrogens out here, and then the hydrogens want to come back in, and so FAD does the same thing, except it happens in the second protein channel. And so, because hydrogen, there's less in here, hydrogen wants to come back in, so it has this ATP synthase, which forces it like a, what did he call it? The
turbine.
Yeah, the turbine. How it's like a turbine that forces it back in, and because there's a random ADP with an extra phosphate, it suctions it together and makes ATP. Something like that. It slaps them together.
Yeah.
Rather, not the hydrogen.
Yeah.
But
So that's why you get more ATP out of an NADH, because it starts earlier at an earlier transport protein, right?
Oh, that's fine.
And so, right, and then, so yeah, basically what we're doing is kind of like a dam, right? When you build a dam, you're blocking up all this water, but then you open it so that the water runs through and spins these turbines, and that generates electricity, right? And you store it and use it as power, right? So basically what we're doing is, are you guys good? Can I erase this?
Yeah.
Okay, so really quick. So basically what we're doing is, so like this right here is basically this. So we've got these so basically what we're doing is NADH comes and delivers its electrons, so it becomes NAD+. And this release of electrons causes this to pump protons up in this space. Okay?
This is the electron
Transport chain, yeah. Okay? And then these electrons go from protein to protein and continue to pump protons like this, until what happens is that you have a really high concentration of protons in this space right here. Okay? And like she said, there's another transport, another protein that basically allows these hydrogens to then pass through, because whenever you have a concentration gradient, it always wants to flow from a high concentration to a low concentration. And so this creates mechanical energy that basically spins this protein, and then it pumps out ATP. And then you can use that ATP in all the reactions that your body needs to go through. So, and then so FADH, it's more like on this one. It goes on this one, so it only goes twice. So it pumps protons also. And so you're pumping less protons for the FADH. That's why you get less ATP per FADH. Because they pump a certain amount, right? It's like, what is it? Did he say exactly how many protons?
I mean, on here it says 4.
4. Yeah, it's like 4, 4, and 2.
4, 4, and 2, yeah.
Yeah. So 4, 4, and 2. So for every NADH, you pump 10. For every FADH, you pump 6. And that's how they figure how much ATP you actually get from that amount of protons. Okay? Because it takes a certain amount to cause a certain amount of spin, basically. Yeah. But I think that's like more than you really need to know about it. But so the goal of metabolism is to create as many NADH, FADH as possible, because in the end, that's what's pumping the protons and causing the production of ATP, right? So let's see. Yeah, so another thing to consider is they might ask you something on the test like how many ATP per acetyl-CoA or per pyruvate, right? That's when you need to be careful about. That's why I made it in like a list, right? So that you can start at a certain point and then go down, right? So like if you start anywhere after pyruvate, you're not timesing by 2 anymore, right? Because you only get 1 pyruvate, so you only get 1 acetyl-CoA, right? If you're starting from acetyl-CoA, no pyruvates, no NADH from all that, just starting from there and going down. So it's important to know the products of each step because they could ask you how many per glucose, so that's everything, right? Or how many per acetyl-CoA, per pyruvate, or what are the products of one turn of the Krebs cycle, right? You could say 3 NADH, 1 FADH2, 1 ATP, right?
Mm-hmm.
Those are like easy questions to get right because it's just simple, like you just memorize what it is in each step.
So glucose takes 2 cycles of the... Okay.
Yeah. Yeah, because it produces 2 pyruvates, which produce 2 acetyl-CoAs, right? Yeah.
So we should basically just memorize this whole thing.
Yeah.
Yeah.
And really, I don't know. It's not a ton of, I don't know. Maybe to me because I've gone over it like 100 times, but it's easier. But, I mean, yeah, that's kind of like the bare minimum of what I would know with glycolysis. And that's with the presence of oxygen too, right? So without oxygen, what happens?
Lactic acid.
Lactic acid, right?
Pyruvates go into lactic acid because they can't, right?
Yeah, so basically in the last step of glycolysis that produces pyruvate, instead of pyruvate, you're producing lactate.
Oh, okay. So it doesn't even make it to the pyruvate
No.
stage.
So that's without oxygen.
Yeah, without oxygen. And the conversion of the last step of glycolysis to lactate costs NADH. And so you lose the ones that you made. Does that make sense? So your only product from glycolysis anaerobic is 2 ATP and 2 lactates.
Okay.
You don't get any NADH. Go
Why
ahead.
would you not get oxygen there? Does that make sense? Is that kind of a dumb question?
No.
But, like, how would the oxygen not get there?
Yeah, it's a good question.
Is that when you're exercising?
Yeah, it's basically that physically the oxygen cannot get there fast enough for the demand of the tissues.
So if you're just like working out really hard.
Yeah, let's say you're like jogging, right? You're able to deliver oxygen at a fast enough rate to the muscle to run glycolysis. But let's say you start running way faster, burning way more ATP, right? And it can't get oxygen there fast enough, but you're still needing energy, so it needs to do whatever it can, basically. And so it does fermentation, right? Lactate, right? It's basically, you'll always do aerobic unless you're not capable of doing it. There's exceptions like bacteria and stuff like that, but...
Is that what causes like lactic acid buildup, like when it burns?
Mm-hmm. Yeah, well, it depends on what you're talking about. Like, if you are sprinting as fast as you can, eventually you can't sprint anymore, right? Your muscles will like cramp up and you'll like fall. That's because you're accumulating so much lactic acid and build up that you can't, like the acid starts to affect
Your body.
the function of the muscles and they can't do that, right? But it clears pretty quickly. So some people think lactic acid is the reasoning behind like delayed onset muscle soreness, so like the next day, but that's not true. It's caused by like micro tears in the sarcomere. But lactic acid can be converted back into pyruvate though. So then maybe that's what you're thinking of, because once you like stop and catch your breath, you're going to start doing glycolysis again, and you can convert lactate back to pyruvate and then go from there.
And that's why it's good to give yourself breaks during that.
Yeah, and that's the idea behind recovery. Like if you ever sprint or do something really fast in soccer, you might only need like 10 seconds to just get your breath, and then you're like right back where you started from. It's because you've just gone anaerobic and you need to recover so that you can, get enough oxygen to the tissues, and then you can start doing glycolysis again. So
is that what like some marathon runners, you've seen those videos where like they literally like can't control their body?
yeah.
Is that because there's so much lactate buildup that it just...
Yeah, well that's one of the factors. I mean, there's a lot of things that go into muscle contraction, like electrolyte balances and stuff like that, or heat exhaustion and things like that. But yeah, if you produce a lot of lactate and stuff, it can mess with like you talking about like spasming muscles and stuff like that.
Yeah, we just watched this video where this lady, like, her legs were just like out of control.
Yeah,
and, like, she had to crawl to the finish
yeah,
line.
yeah, that can happen.
Really?
Yeah, it
But
was insane.
usually marathon runners are going aerobic though, right? Because to run 26 miles, you have to be doing glycolysis. There's no way you could do that. But like sprints to the finish, like at the finish of the race, they're gonna probably go more into anaerobic, right? Because they're sprinting and like just hauling.
I know we're 1 minute over, but what's the difference between aerobic and anaerobic again?
One is in the presence of oxygen, one's without oxygen.
Okay, just wondering.
So aerobic with oxygen, anaerobic without. Yeah.